Hello and welcome. In this video, we'll talk on the 11th problem from the book Pattern Recognition by the author Christopher Bishop. This problem is around Gaussian distribution. We'll look at the problem. So normal distribution equation is given to us, and we know that X is a data set X, in which elements are independent and identically distributed. So probability of observing the set given mu and sigma square is given by the product of all the normal distributions for xn's given uh, that mean is mu and variance is sigma squared. Now, if we take the log or natural logarithm of this, we get the log likelihood function, which takes this form. We'll look at its explanation in a bit, but let me phrase the problem right now. So if we maximize equation 1.54, which is log likelihood function equation, if we maximize this equation with respect to mu, we get this expression mu ml equals to 1 by n summation of xn. And if we maximize this equation 1.54 with respect to sigma squared, we get this expression 1 by n summation of square of difference of xn minus mu ml. Now that is the question. How are we, when we set the derivatives of log likelihood function with respect to mu and sigma square equal to 0, we have to verify the results that mu ml is equal to this expression and the expression for sigma squared is 1 by n summation of squared of differences of xn and mu ml. Now this we have to prove. We have to derive expressions 1.55 in equation 1.56 from the equation 1.54. Now let's take a look at the solution. We got this solution from ChatGPT. I gave it some prompts and I led the ChatGPT to output the solution. So first I asked it what is Gaussian distribution. It is the same expression which we saw a minute back in the page. Now I ask it what is the log likelihood for it. It gives me the expression. Then I ask it, can you show me how you arrived at it? So it tells me that this is the normal function, this is the probability, this is the likelihood function, this is the likelihood function, then log likelihood is taking the logarithm of this likelihood function, which is this summation of ln f of x I given mu and sigma. Now over here you can see that it is saying log likelihood equals to summation of natural logarithm of Gaussian distribution. Now we'll do some paperwork and prove it to ourselves that this actually turns out to be the case, that when we solve this logarithm, we actually get this expression. So for that, we need to understand three identities, that logarithm of x dot y is equal to logarithm x plus logarithm y. Logarithm of x raised to the power b equals to b logarithm x, and logarithm of Euler's constant is equal to 1. Natural logarithm of Euler's constant equals to 1. ln here means natural logarithm with the base e, with the base equals to Euler's constant. Now, as you can see, we have this expression. We solve this using the product rule, that natural logarithm of x dot y equals to logarithm x plus logarithm y. Then we expand it to three terms: logarithm of 1 by sigma plus logarithm of 1 by root 2 pi plus 1 plus logarithm of exponential of x minus negative of x minus mu squared divided by 2 sigma squared. Then we use the power rule, where logarithm of x raised to the power b equals to b logarithm of x to solve this thing, logarithm of 1 upon sigma. Next, same formula we use to solve the logarithm of 1 upon root 2 pi. Then this formula again comes into use over here as we solve the exponential expression. We bring the power as a constant as a multiplier to the logarithm function, and inside the logarithm just e is left. And we know using the identity logarithm of e base e equals to 1. This implies we come at the same solution which we are seeing over here. Negative of, well, where is this n coming from? This n is coming from the summation. I can see that n is not here in this mentioned in this paperwork. So n is coming because of the summation. What we solved is just this expression. This inside, what is inside. The summation part is still pending. What we solved is just what is inside these brackets. Now next is I asked the ChatGPT, can you maximize the log likelihood expression with respect to mu and show the detailed steps? Then it differentiates the does the differentiation for me with respect to mu, and all of these terms are except this one. These two terms are independent of mu. So just this term will be left. Then we'll use the rules of derivative. I'll show the rules of derivative right next. It says that derivative differentiation of log likelihood with respect to mu is 1 by sigma squared summation of difference of xi and mu. Now we'll prove it next. What we have over here is we need to understand three identities. Derivative of x to the power n equals to n into x raised to the power n minus 1. Derivative of f of x raised to the power x equals to n f of x raised to the power n minus 1 dot f dash x. F dash x is derivative of fx. And derivative of ln log natural x equals to 1 by x. Now, over here, if we look at this derivative, this is simple. We use these entities. This is an expression of mu. So this uses the second identity which was shown over here. The second entity is being used. We have an expression that looks like a function of mu. So we first solve the power. We take out the constant. We solve for the power. And then we solve for the f of x, which is xi minus mu. Then on rearranging the terms a little bit, we arrive at, so basically this is summation, and derivative of summation, the derivative of summation is derivative of all the summation of derivatives of all the individual terms. So wherever there is power, that power will come down, one will be left, and we simply get summation of xi minus mu. And what comes after is derivative of xi minus mu, as shown by this given in this second identity in this slide. Now, and hence we arrive at this point where we have proved it to ourselves that, and then we set it to equal to 0. So we'll get this expression expanding the sum. Xi will take the summation, and what will come with mu is n, summation of mu n times. So it is n mu, it becomes n mu, and then mu expression for mu can be, then the equation can be rearranged to get the expression for mu. Now last thing is, we now ask ChatGPT to maximize log likelihood function with respect to sigma squared and show the detailed steps. So this is also simple. In this, what we do is we assume that our variable is sigma squared itself. So this is a straightforward thing. This will become 0. This would then over here, as you can see, derivative of ln x is equals to 1 by x. So this would be minus n by 2 multiplied by sigma squared. And this part is independent of this expression inside summation is independent, is not containing sigma squared. So this will be treated as constant, and we'll use the power rule to solve for the expression 1 upon sigma squared. And we'll set it to equal to 0, rearranging the terms a little bit. We get our required desired result at sigma square equals to 1 by n summation of square of difference of xi minus mu. Now I have shared this link to ChatGPT's chat history. You can go through it. And that was all for today. Thank you for joining.